In this video, you will learn how to move on-premises data to the Azure cloud using Self-Hosted Integration Runtime in Azure Data Factory. You will see how to initialize a Git repository in Data Factory so your pipelines are version controlled. For reliability, you will set up Azure Logic Apps for email alerts. This way, you will get mail if pipeline succeeds or fails. For monitoring, you will set up Azure Monitor to track pipeline health. Next, you will learn how to use Azure Key Vault and Databricks Secret Scope to secure the data. This way, data will be secured when moving between Azure Storage account to Azure Databricks. You will then learn how to clean data in Azure Databricks and move the clean data back to Azure Storage account. Then you will set up Azure Synapse Analytics to gain insights from the data in SQL pool. Finally, you will develop a professional Power BI report. The tools and services we will be using include Azure Data Factory, Azure Data Lake Gen 2, Azure Logic Apps, Azure Monitor, GitHub, Azure Databricks, Azure Key Vault, Azure Synapse Analytics, Power BI, and Microsoft Integration Runtime. Ladies and gentlemen, I hope you're having an amazing day. Today, we're going to do a complete end-to-end Azure Data Engineering project that you can actually practice yourself. This project will help you understand how real data engineers move on-premises data to Azure Cloud, transform it, secure it, and then turn it into valuable insights. By following along, you will get hands-on experience with multiple Azure services. So, if you are preparing for interviews, certifications, or just want to learn how all these services fit together, this project is for you. Let's dive in. Let's go step by step through the architecture of our project. We will begin with the on-premises environment, where the data is stored. This simulates a real-world scenario where companies often have legacy systems or local databases producing flat files. To bring this data into Azure, we will use Azure Data Factory. Now, because our data lives on-premises, we need a secure bridge to the cloud. That's where Self-Hosted Integration Runtime comes in. It acts as a secure gateway installed in the on-prem environment, which allows Data Factory to connect and transfer the data securely without exposing it publicly. Inside Data Factory, we will also enable Git integration. This is an important enterprise best practice because it allows us to store pipeline definitions in a Git repository. With Git, every change to our pipelines is version controlled, team collaboration becomes easier, and rollback to previous versions is also possible. For reliability, we will build monitoring into the pipeline, and for that purpose, we will use our Logic App to send email notification whenever the pipeline either succeeds or fails. This way, the data engineering team is always informed about pipeline health in real time. In addition, we will also configure Azure Monitor, which gives us dashboards, logs, and alerts for deeper pipeline tracking and system-wide monitoring. Once the data is ingested, it will be stored in Azure Data Lake Storage Gen 2. This acts as our central data lake, where we can keep both raw data and processed data in a structured hierarchical format. Data Lake Gen 2 is scalable, cost-effective, and designed for big data analytics. Now, once the data is in raw data container in storage account, we need to prepare it for analytics. For this purpose, we will use Azure Databricks. Databricks allows us to perform large-scale data cleaning and transformation using Apache Spark. This is where we will handle tasks like removing duplicates, correcting data formats, and preparing clean datasets for analysis. But when Databricks connects to external systems, like here Azure Storage account, it needs credentials. Hard coding these credentials is a big security risk. To solve this, we will use Azure Key Vault together with Databricks Secret Scope. Here's how it works. Key Vault stores all the secrets securely, and Databricks Secret Scope acts as a link between Databricks and Key Vault. So whenever Databricks needs a secret, it retrieves it securely from Key Vault, and the actual credentials are never exposed in code or notebook. This is a critical best practice for enterprise-grade security. After transformation, the clean data will be stored into Data Lake Gen 2 container named Transform Data. From there, we will connect to Azure Synapse Analytics, which allows us to query this data using familiar SQL. Synapse can handle big data queries efficiently and is well suited for building data warehouses and analytical solutions. Finally, we will connect Power BI. Power BI will serve as a visualization and reporting layer, enabling us to build interactive dashboards where end users, managers, or analysts can explore the insights. Let's download the data and take a look at our dataset. In the search bar, enter Marvin Analytics and then click on the first link. Now go to Discover, click on Resource, and from here click on Data Playground. Here you can see all these data sets and there are categories given too. Alright, so the data we will be working with is this CRM sales opportunities. So click on View Details and click on Preview Data, and you can see there are 5 tables, this and alright. So what we will do here is we will download the data set, and once you download the dataset, extract it. Now what I have done is I have extracted the data. So as you can see, here is my data, and these are the 5 tables: accounts, data dictionary, products, sales pipeline, and sales team. Now let's view the data one by one. Now as you can see, these are the company's data, and these are the companies here, and this is the sector in which these companies are from, and this is the established date of these companies, and this is the total revenue, and this is the employees. Each of these companies have the office location and the subsidiary information too. Overall, you can see this is all the company data. Okay, so let's view the other tables. Data dictionary. This is a data dictionary table, and this basically contains information about the column names. Like in the products table, there is a product, and what it means is that it contains the product names. And similarly, in the products, there is the sales price, which means that suggested sales price. And basically, it's just a dictionary. And for the next table, products, this table contains the price of each of the products. Okay, so that's it. And for the sales pipeline, now this is a sales pipeline table. It basically contains the sales agents and the products which they are selling and the deal stage. There are basically 3 deal stages: one, engaging, or lost. These are the 3 stages, and there is the engage date, and then there is a close date and close value. Okay, so let's move on to the next table. This contains the sales agents names and who is their manager and where their office is located. Now let's move these tables to Azure Cloud. Go to search and type portal.azure.com. Okay, and then enter. You might need to sign in or sign up. Once you have signed in, a portal will open where all the services of Azure will be there. Once the portal opens, click on search and type here resource and click on resource groups. Resource group is actually a logical container for managing related Azure resources. By grouping resources with the same lifecycle, you can easily deploy, update, and delete them as a single unit. Click on Create, enter the resource group name, and that will be Azure UAE North RG. Next, select the region. You have to select the region which is closest to you. And since UAE North is closest to me, so I will select this region. But otherwise, you can select any of these regions which is closest to you. Okay, next. Now these are the tags. Tags act like sticky notes for your resources. They actually help identify, organize, and manage costs efficiently. Tags in Azure are key value pairs. This is the key and this is the value, okay, that you attach to resources, and they help in organizing resources. I will just leave it as it is and click on next and click on create. Once the resource group is created, again go to search and type here storage and click here storage accounts. Click create storage account. Now you can see a resource group and select the resource group which we created. Next, for the storage account name, let's give it a name Azure UAE North and ST for storage account, okay, and the region will be UAE North. Preferred storage type. When creating a storage account, Azure lets us pick the storage type based on our needs. Let's say we have the unstructured files like videos or logs, or we have to perform analytics or big data pipelines, then we will select the blob storage or Azure Data Lake Storage Gen 2. And if we need a shared network drive in the cloud, then we will select Azure Files. And if we have lightweight apps or messaging, then we will select the tables and queues. But in this project, since we are working with data in files and folder structure, we will go with blob storage. Next is performance, and we are given two options, standard or premium. Premium is basically for the scenarios which require low latency, but we will select the standard, and this is basically for most scenarios, as you can see here. Next is redundancy. In Azure, redundancy means how many copies of your data are kept and where. So there are four types: LRS, locally redundant storage; GRS, geo-redundant storage; ZRS, zone redundant storage; GZRS, geo-zone redundant storage. I will explain what each of these means. So LRS, locally redundant storage, keeps 3 copies in one data center, and it is the cheapest but least resilient. Next is GRS. GRS only adds geo-replication. What it does is it adds another 3 copies in a paired region. Next, zone redundant storage, ZRS. It spreads data across 3 zones in the same region. So what is the difference between LRS and ZRS? LRS stores 3 copies in one data center in the same region, and ZRS spreads data in 3 zones in the same region. Last is GZRS, Geo Zone Redundant Storage. It combines both GRS and ZRS, and it is the most expensive option too. So we will go with GRS, Geo Redundant Storage. Next. Now here's the security configurations. First is require secure transfer for REST API operations. If we turn this on, our storage account will only accept secure HTTPS connections, and it will make sure that all data is encrypted when moving in and out. If we leave it off, apps could still connect over unencrypted HTTP connections, which is a security risk too. So for the best practice, we will keep it enabled and allow enabling anonymous access on individual containers. If this is turned on, we can make some containers public, meaning anyone with a link can read the data like images or files for a website. And if it's off, all containers require authentication and stay private. And we will keep this disabled, but if you're hosting public files, you might enable it for just those containers. But beware that if anyone has the link, then they will have access to all the data. Okay, and next is enable storage key access. So when you enable it, you allow applications and users to authenticate to the storage account using one of its access keys. Let's say you want to send data from your Azure Storage account into Power BI to build a dashboard. And to do that, Power BI needs to connect to the storage account. And one way to authenticate that connection is by using a storage account access key. And if this key is enabled, you can copy the access key from Azure and use it to connect Power BI to your Azure account, Azure Storage account, allowing it to read the data. But this is risky too, because if the key leaks, someone could take full control of the data. Next option is default to Microsoft Entra authorization in the Azure portal. If we enable this option, Azure portal will use our Entra ID roles to control access to the storage account instead of relying on the storage keys. This is more secure, but since we have already enabled storage account key access, we will leave it disabled. Next is minimum TLS version. TLS here means transport layer security, and it is the encryption protocol that protects our data while it's being transferred. Older versions like version 1.0 and version 1.1 are outdated and insecure. So the best practice is always to set this to version 1.2. Next is permitted scope for copy operations. Let's set it to from any storage account. Next is hierarchical namespace, and this is very important. Okay, because enabling this option will make our storage account into our data lake storage gen 2. And if we enable this hierarchical namespace, the storage account works more like a real file system with folders and directories. Azure Storage also gives us the option to enable SFTP. And what this does is this allows the storage account to work more like an SFTP server. So we can securely upload and download files using standard SFTP clients. Next option is enable network file system v3. This allows us to mount our storage account directly on Linux systems, so applications can read and write data as if it were a local file system. It's basically useful for big data or machine learning workloads. And both of these options require hierarchical namespace to be enabled. For example, if I disable it, then none of these options would be enabled. So the next is blob storage. Allow cross-tenant replication. What this means is, if we enable this, we can replicate data across storage accounts that belong to different organizations. This is useful when you want to share data with a partner company or replicate data to another tenant for backup. But it also requires careful security control. So you would only enable it if you truly need cross-organization replication. Next is access tier. It defines how often you expect to access the data and on what pricing. And there are three tiers: hot, cool, and cold. Cold is also known as archive tier. So hot is the most expensive one here, and cold is the most least expensive. Hot is for data you use frequently, is fastest but costs more to store, and it's basically for analytics. Cool is for data you access less often, like monthly reports, and it is cheaper to store but more expensive to access. And finally, cold. Cold is for rarely accessed data, like historical data. It is cheapest to store, but it takes time, a lot of time to extract the data. Okay, and since we will be doing analytics on data, so we will select here hot tier. Next is enable large file shares. It is enabled by default. Next. Now this is the networking category. And the first option is public network access. And there are three options: enable, disable, or secure by parameter. And what it does is it controls how clients connect to your storage account. And enabling it means anyone with the right keys or tokens can connect from the internet. Disable will mean that only private endpoints can reach storage. And secure by parameter is the most restricted option. And what it means is it allows access only from trusted networks or Microsoft services. And next is public network access scope. This comes into play if you choose enable for public network access. And enable from all networks makes your storage reachable from anywhere on the internet as long as users have the right credentials. And enable from selected virtual networks and IP addresses. What it does is you allow access only from trusted IP ranges or Azure VNets. VNets is virtual networks. For example, you could limit access to just your company's office network. And this is private endpoint, and it lets you connect your storage account directly into your virtual network with a private IP address. And in order to add private endpoint, you will need a virtual network too. Next option is network routing preference. When your storage account is publicly accessed, you choose how requests are routed between clients and Azure. With Microsoft Network Routing, data travels through Microsoft's private backbone network, giving us lower latency, more consistent speed, and better security. With Internet routing, data goes over the public internet, which is cheaper but less secure and can have higher latency. For this project, since we want better performance and reliability, we will go with Microsoft Network Routing. Next, now this is the data protection options. The first option is enable point-in-time restore for containers. If we enable it, we can roll back a blob container to an earlier state. For example, before someone accidentally deleted or overwrite files, Azure keeps versions and logs of changes for our retention period we set, up to 365 days. This is useful for protecting against accidents or corruption, but it also increases costs. And one thing to note here is that this option and hierarchical namespace option cannot be enabled at the same time. For instance, if I enable it, then you can see point in time restore and hierarchical namespace cannot be enabled simultaneously. So we will keep it disabled. Next three options enable soft delete for blobs, containers, and file shares. These are same things. And if we enable it for blobs, containers, or file shares, deleted data isn't gone right away. It's kept for a certain number of days. Minimum is 1 day. And for example, if I say 0, then you can see here 1 and 365. So I will just say here 7 days. And during that time, we can easily restore it if someone deletes or overrides something by mistake. It's basically a recycle bin for Azure Storage. Okay, and the next option is tracking. Enable versioning for blobs. If we enable this option, then whenever we update or overwrite a blob, Azure saves the old copy as a version. That way, if we make a mistake or overwrite something important, we can go back to a previous version and restore it. And this is different from soft deletes, which protects against accidental deletions. Versioning protects against accidental changes or overrides. Also remember that costs do increase if files change frequently as Azure will be storing old versions too. Next option is enable blob change feed. If we enable it, what Azure will do is Azure automatically writes a log of every blob event, whether a file was added, updated, or deleted. This log is stored in a system container. Final option in data protection is enable version level immutability support. If we enable it, we can lock specific blob versions so they cannot be changed or deleted until a retention period we choose. For example, 7 years. This is especially useful for compliance scenarios in industries like banking or healthcare, where records must be preserved exactly as they were. So click on Next. Next is encryption. Azure Storage account encrypts all data at rest, but we can choose the encryption type. With Microsoft Managed Keys, this option, Azure handles everything automatically, and this is used for most scenarios. And with customer managed keys, we bring our own keys from Azure Key Vault, giving us more control and compliance for sensitive data. And the next option is enable support for customer managed keys. And there are two options, blobs and files only or all services types. If we enable customer managed keys, Azure asks where to apply them. We can pick blobs and files only or all service types, which includes blobs, files, tables, and queues. If we only need compliance for file data, the first option is enough. But if we want full coverage across every service in the account, so then we would go with the second option. Next option is enable infrastructure encryption. And if we enable this option, we add a second layer of encryption, and this is called double encryption and is mainly used for very sensitive workloads like finance or governments. For most projects, standard encryption is enough, but for highly regulated industries, this option gives stronger protection, and we will keep it disabled. Next, tags. Next, once the validation completes, you can see here is the options which we selected and click on create. Once the deployment is completed, we will have to select where our data will be moving to. So click on go to resource, and you can see here are a lot of options like data lake, storage, security, and in the left menu there are overview, activity log, tags, data migration, events, storage. But you have to go to the containers under the data storage. Click on it and add container, and this will be our raw data container, and click on create. And again click on add container, and this time it will be transformed data. Now raw data is where our initial data will be coming to. Now we need Data Factory in place. So open Microsoft Azure in another tab, remove this, and search here Data Factory, and click on this Data Factories, click on create. Now choose the resource group Azure UAE North RG, and our data factory name will be Azure UAE North Factory. Okay, and the region will be UAE North, version V2, and next. Now when setting up data factory, Azure asks if we want to configure Git now or later. Git integration lets you version control your pipelines in Azure DevOps or GitHub. We will configure Git, but after deploying Data Factory. So for now, let's enable this option. Next, and this is the networking option, and the first option is enable managed virtual network on the default Azure Resolve Integration Runtime. So integration runtime is basically the compute engine that runs your pipeline. And by default, the integration runtime in Data Factory runs on a public network, and this is the default integration runtime. If we enable managed virtual network, Data Factory creates a secure environment where pipelines run inside a private Azure VNet. This means our data flows through private endpoints instead of the public internet. And this is the best practice for enterprise projects, but for this demo, we will skip it. But in real projects, enabling this is strongly recommended. And the next option is connect via public endpoint or private endpoint. With public endpoint, the connection goes over the internet but is fully encrypted. With private endpoint, the connection stays inside Azure's private network, and which is more secure but needs extra setup. So we will go with public endpoint. Next, and in the advanced section, there is the option enable encryption using a customer managed key. By default, Data Factory encrypts its data with Microsoft managed keys, but we can also enable customer managed keys. This means our Data Factory uses a key that we provide through Azure Key Vault. You can see here is a Key Vault URL and user assigned identity for encryption. And this gives us full control over the encryption. We can rotate or revoke the key anytime. But for now, we will leave it as it is. Next, tags. Next, review plus create. Click on create. Once the Data Factory is deployed, click on go to resource. And you can see here is our Data Factory. Click on Launch Studio. Once the Data Factory opens, click here. And you can see there are some options: Home, Author, Monitor, Manage, and Learning Center. Home is the landing page. It gives you quick shortcuts to creating new pipeline, Power Query, data flow, and dataset. And you can also access pipeline templates from here. Okay, and the next is Author. Author is the workspace where you build pipelines. You can create pipelines, change data capture CDC, datasets, data flows, Power Query. And in the Monitor section, it is used to track and debug pipeline executions. Next is Manage. Manage is the administration hub. Here you configure linked services, integration runtimes, Microsoft Purview, and mount Data Factory to Microsoft Fabric. And for the source control, there is Git configuration, ARM template, and author, and etc. And finally, in the Learning Center, this is built-in learning and help hub, and it provides tutorials. You can see here tutorials, samples, templates, and videos, and it's all learning. Okay, so let's go to the manage, and first we will configure Git here. Let's configure a Git repository first. Okay, so go to new tab and open GitHub. Click on create repository. You can also select from here create new and new repository. Okay, and let's name it Azure UAE Azure UAE North repository. Okay, so this is the name of our repository, and visibility will be private because it will contain information about linked services and our pipeline. Okay, so set it to private and skip everything else and just click on create repository. Okay, so now let's go back to where our data is, and from here open git bash here. If you don't have downloaded the Git patch, then you can easily download from the Chrome. Now the first step is to initialize Git. So write here Git init. Okay, now you can see Git folder appear in our folder. And the next is Git add dot. What it will do is it will add all these files into Git. And now we have to write git commit dash m initial commit. Okay, I did a spelling mistake and that will be git commit. Now we have to give the branch where commit will be done. So it will be git branch dash m main and git remote add origin, and here we have to give the link of our repository. By the way, these are the same steps here too. So paste in here and enter. And finally push it. Git push dash u origin and main. Okay, so now if I go back and refresh it, then you can see all my data is here too. Okay, now click on main and click on view all branches, and you can see we have only one branch here, and that is main. Now if we connect our data factory to this main, then everything will be uploaded to the main branch. But in the real enterprise environments, we upload data to development, test or production branch, and from there it is copied to the main branch. Okay, so let's create a new branch here, and that will be dev. Let's name it dev and click on create new branch. Okay, and let's go back to the code and dev branch. You can see everything is here too. Okay, so now let's go back to the data factory and click on configure. Select the repository type. There are two options, Azure DevOps Kit or GitHub. We will select GitHub and the GitHub repository owner. Who is the owner? Go to profile and this is the owner. Paste it here. Okay, and there are two options, select repository or use repository link. And if I do repository name, that will be, this is our repository name, and collaboration branch we will go with dev, and publish branch will be adf publish. Now for the root folder we will name it, let's say, data factory. Otherwise, if we don't give the root folder, then what it will do is, let's go back here and you will see here a folder named data factory, linked services, and everything here will be a bit of mess. So I'm creating the data factory folder here. Then in the data factory everything will be there. Click on data factory and import resource in this branch, and this will be dev, and click on apply. Alright, now we have configured the repository. Now you can see dev had recent pushes, and click on create and pull, and you can see here is our default data. Now that we have configured our repository, in the next part we will create a integration runtime, a self-hosted integration runtime. Now in order to connect data factory to our own premises system, we need integration runtime, a self-hosted integration runtime. So click on integration runtime, and you can see this auto resolve integration runtime is already running. This is the default integration runtime that Azure provides. And for most cloud-to-cloud data movements, this runtime is enough. But if we need more control, like choosing a region or setting up private networking, we can create our own custom integration runtime by clicking here. Click on New. And there are three options: Azure Self-Hosted, Azure SSIS, Airflow Preview. The first here is Azure and Self-Hosted, which covers most use cases, either cloud-to-cloud pipelines with Azure IR integration runtime or on-premises connections with Self-Hosted Integration Runtime. The second is Azure SSIS, designed for migrating existing SSIS SQL Server Integration Services packages into the cloud. The third is Airflow Preview, which allows us to orchestrate Apache Airflow pipelines inside Data Factory. So we will go with Azure and Self-Hosted. And here we have three options: Azure, Self-Hosted, and Link Self-Hosted. The main difference between both of these, self-hosted and linked self-hosted, is that self-hosted normally belongs to a single data factory, but with linked self-hosted integration runtime, we can share the same runtime across several factories. This means we don't have to install and manage multiple runtimes. For example, if my finance and marketing teams both need to connect to the same on-prem SQL server, I can just link them to one shared self-hosted integration runtime, saving time and cost. Okay, so we will click here self-hosted. Let's name it on premises on-prem to Azure integration runtime. Okay, and click on create. Now we have two ways to set up integration runtime. First is express setup and the second is manual setup. Express setup is good for quick demos. It installs everything with default settings, so we're ready to connect on-premises data in minutes. But for production, companies usually go with manual setup, this one here, because it lets them choose custom service accounts, proxy settings, and firewall rules for better security and compliance. We will choose manual setup here. Now select the language as English and click on download. And you can select any of these integration runtime, and I will go with this one. This is the latest one too. Once it downloads, click on the integration runtime. Next, and accept the agreement, and the next, and install. It will take some time to install, so let's wait. Once the setup completes, click on finish. Now we need a key here, okay, and the key is one of these keys. Now copy one of these keys and paste it in here. And if you need a proxy, then you can change it from here and click on register. Enable remote access from intranet, and next. Enable remote access without TLS or SSL certificate, and next, and finish. Now that integration runtime has been registered successfully, click on Launch Configuration Manager. And you can see from here, self-hosted node is connected to the cloud service. Now close it and refresh it. You can see it's running. Now what we have done is we have connected Azure Cloud to our own premises system. Now we have to give the location, exact location where our file is, where our folder or file is, which we have to move to cloud. So for that purpose, we need linked services. Let's create the link services now. Click on link service and click on new, and from here you can see there are multiple data stores. All right, but since our data is in files and folder structures, and you can see this is the file and folder structure, so we will go with file system, and let's name it file location, and connect via integration runtime will be on-prem to Azure Integration Runtime. Okay, now this is our location where our file is, so we will give it as this. So just copy this path and paste it in here. Now username and password. Now this username and password is your computer's original username and password. So my username is, now let's test connection. It has given us an error, and what it is, it says that access to the location is not allowed. So now let's fix it. So go to the file explorer and click on C drive, and from here program files, and then Microsoft Integration Runtime 5.0, and then shared. Okay, and then copy this path. Now click on Windows and open PowerShell and run as administrator. And now here write cd space strings, and in between strings paste, and now enter. Here write dot slash dmg cmd space dash disable local folder path and validation. And here you cannot make any mistake, and as you can see, the first letter of each word is capital, so keep it as it is. Enter. All right, now minimize it and make sure that integration runtime is running. Okay, it's saying self-hosted node is connecting to the cloud service, so let's wait for it to connect, and then we will try again. Once it is connected, minimize it and test connection again. Now you can see the connection is successful. Click on create. Now that we have successfully created the integration runtime and linked services, now we are ready to build the pipeline. So click on author and go to pipeline and click on these dots. Click on new pipeline. Name the pipeline as, let's name it on-prem to cloud. On-prem to cloud. All right. Now you can see there are activities here: move and transform, Synapse, Data Explorer, function, batch service, Databricks, Data Lake Analytics, General, HD Insight, iteration, conditionals, machine learning, and Power Query. So now search here copy activity. Now click on source, and for the source data set, click on new, and here type file and click on file system, and click on delimited text since our data is in delimited form. And for the link service, select the link service which we earlier created and browse. Now you can see here is our data. So select the first one, accounts, and OK. And first row is header. Import schema will be from connection or store. and OK. Alright, now you can see there are some options here like file path and open new preview, and you need not to worry about any of these things, but you can preview your data by clicking on preview data. You can see here is our data, so close it. One thing I forgot is I have to rename it, so I will open it and change its name to account source. Account source. Alright, now save it. Okay, now close it, and you can see its name is changed to account source. And for the sink is where our data will be going to, and this is the storage account container named raw data. Okay, so click on new and Azure Data Lake Gen 2 and CSV, and let's name it sink because it's the same for every file, because every file will be going to the data lake storage gen 2 container raw data. Link service will be new, and this time integration runtime will be resolved because the data will be going from cloud to cloud. For the authentication type, we will go with account key, and SES is shared access signature, and there is service principal, system assigned manager entity, user assigned manager entity, but we will go with account key. Okay, select the Azure subscription, select the storage account, and then test connection. Okay, connection is successful, and click on create. Now we have to give the file path, the location where the data will be going to, and that is raw data. And first row is header, import schema will be from connection or store. Now this is done. One last thing we have to do is we have to change the name of the copy activity, and that will be accounts. Now similarly do this for all other activities too. So this name will be data dictionary, and source will be new, file, file system, delimited text, and file location, data dictionary. The name will be data dictionary source. Okay, now go to sink and select the sink as sink, because all these files will be going to the same location. And similarly again copy data, and this time click on new, file, file system, delimited text, and file location, and products. Name will be changed to products source, product source, and first row will be header, import schema will be from connection. Okay, now if we preview the data, okay, data is loaded. Now for the sink, it will be sink. Let's rename it, and products. Now let's do the next. Let's reorder it, data, products, and then there is this one. Okay, file, delimited text, and file location, the name of the file. Now select the sales pipeline. Let's rename it to sales pipeline source, and the rest is okay. Preview the data. Okay, the data is loaded successfully. And now for the sync, it will be sync. First rename it sales pipeline. Now for the last file, and for the source file, file system, delimited text. First let's do it file location, and file name is sales teams. So let's rename it to sales teams source. Okay, let's preview the data. It's okay, and for the sync, it will be sync. Let's rename it to sales teams. Okay, now let's do the ordering. If this succeeds, then this will run. If this succeeds, then this will run. If this succeeds, then this will run. Similarly, this one. Okay, now our pipeline is ready. But if we go back to our architecture, then you can see before the data go to Data Lake Gen 2, we need Logic Apps and Azure Monitor. Logic Apps so that if when the pipeline succeeds or fails, we will get email, and Monitor for monitoring the pipeline. Let's add a Logic App to get notified if pipeline succeeds or fails. Search here Logic App, Logic, Logic Apps, click on Add. Now here there are some options in hosting plans, consumption and standard. For this project, we will use a consumption multi-tenant. That means Microsoft manages the infrastructure and we only pay when the workflow runs. It's serverless, auto-scales, and is perfect for demos or small projects. But the trade-off is that it has fewer networking and performance guarantees compared to the standard plan, this plan here. And in the standard, we can choose a workflow service plan for dedicated compute. You can see the compute is dedicated. App service environment for fully isolated and private deployment. And a hybrid plan to securely connect on-premises and cloud resources. So click on select and select the resource group, and that is Azure UAE North RG. Now give the Logic App name, and that will be Azure UAE North Logic, and region will be UAE North. Log Analytics next, and next. Click on create. Once the deployment completes, click on go to resource. Click on add a trigger. Here type HTTP, and when an HTTP request is received, click on it. Now we write here what we will be getting in the mail. Like for example, if we want the pipeline name, pipeline status if it succeeds or fails, or the time when the pipeline succeeded or failed. Okay, so it will be some code here, and it will be type object properties. Now here we will write our write the things we will be getting in the mail. Pipeline name, type string, and then similarly status, type string, id. Let's just copy paste it, and then finally the time. Now click on this plus icon and click on add an action, and we will be getting an email. So write here Gmail and send email. Connection name, you can name anything here, but I will keep it as it is. And authentication will be used default shared application, and sign in. Select your account and continue. Continue. Now write here your email, where you will be getting notification email if pipeline succeeds or fails. And for the advanced parameters, we will get subject and body. Subject will be pipeline run report. Body will be pipeline details. Now here we will be getting pipeline name, pipeline status, ID, and time. Click on this icon here, and you can see here is the pipeline name which we gave in the HTTP request, and for the status, and ID will be ID, and time will be time. And you can also see the code view here. Alright, so now save it, and when you save it you will get HTTP URL here, so copy it. Okay, now go back to the data factory. Now search here web activity. Okay, now this web activity name will be success, and for the URL will be this. Method will be post, and body, click on add dynamic content. Here we will give the Logic App body details. Pipeline name, here will be at the rate, and then pipeline dot pipeline. Okay, and comma, and there will be status, and status will be succeeded, because this activity is when the pipeline succeeds. And then there will be run ID, and pipeline dot run ID. Yes, and finally there is time, and time will be at the rate UTC now. Okay, this is done now. Okay, and now web activity, and this one for when the pipeline fails. Okay, so let's copy this and paste it in here, and the method will be post, and body will be similar, just what will change is just the status will change. And here, okay, so instead of status succeeded, there will be failed. Now how it will work out is that when the pipeline is success, then it will be success activity, and when pipeline fails, fail web activity. Now Logic App is set up, it's incorporated into pipeline too. Now the next thing we will do is we will add a monitor, Azure Monitor. So now let's monitor the pipeline with Azure Monitor. Okay, so search here monitor, and this one monitor, click on it, and you can see here are a lot of things like alerts, metrics, logs, analytics, workbooks. All right, so click here on metrics. Now if we expand the resource group, then we can see there are multiple Azure services which we can monitor. Let's choose Data Factory, apply. These are the metrics that we can monitor, and for the metric, let's say failed pipeline runs metric, and let's set it to count. All right, let's add another metric, and this time it will be for pipeline runs metric. This will be when the pipeline succeeds, and this will be for when the pipeline fails. Okay, and now let's go back to the data factory. Now let's validate the pipeline if everything is okay. Okay, all right, pipeline is good to go. Now there are some ways in which we can debug the pipeline. Either we can just click on here and it will start the debugging as soon as we click on it, or we can also add a trigger. Let's create a new trigger. Now let's rename this trigger, and this will be, let's just name it trigger. Now in triggers there are multiple types. For example, schedule, tumbling window, storage events, and custom events. And I will explain what each of these means. Schedule. Schedule is like setting an alarm clock. You tell Data Factory exactly when and how often to run your pipeline, daily, hourly, or weekly. And for the tumbling window, this is for when you want to process data in fixed time set. And it's great for scenarios where every hour or day of data must be processed completely and in order, such as hourly sensor readings. And for the storage events, this is events based trigger. Instead of waiting for a schedule, the pipeline runs automatically whenever new data appears in the storage. Now for the last, custom events. This is the most flexible trigger type. Pipelines run in response to custom events sent through Azure Event Grid. This is useful when you want pipelines to start only after specific business events occur, like a report being generated or an external system signaling that data is ready. Okay, so we will select the schedule and let's set the time. The time will be, it's 3:51, so I will set it to 3:55. All right, and okay, 355 and every 15 minutes, every 15 hours. Okay, so specify an end date. All right, okay, okay. Now it's saying that make sure to publish for trigger to be activated after clicking save, meaning that we have to publish the pipeline after clicking save here. I have published it. So now let's wait for the pipeline to publish. As you can see, these are the changes which will be sent to the GitHub too. Okay, so click on OK. Now if we go to the monitor, then we can see that the pipeline has triggered now. Okay, so let's click on it, and now we can see these activities has run successfully, and you can see the pipeline is a success, and now we should get an email too. Okay, so if I go to my mail, then you can see here is my here is the detail which I had given. Like I had given that I want to get name, status, ID and time. All right, so these are the details. And now if we go to the monitor, Azure Monitor, and set it to last 30 minutes, then we can see one pipeline has succeeded. And the good thing about Azure Monitor is we can add a new alert rule here, or we can save to dashboard by pinning it to dashboard or pin to Grafana or send to workbook. Let's do a quick recap of what we have done so far. So we had on-premises data in CSV format, and we wanted to move the data to Azure Cloud. So firstly, we created the Azure Storage account, and we enabled the hierarchical namespace there. And then we created two containers there. First, raw data, and the second, transform data. And we wanted to move our data in raw data. So for that purpose, we created the Data Factory. And in Data Factory, we utilize Self-Hosted Integration Runtime. And then we created the link service to give the exact location where our data is. After that, we build the pipeline in Data Factory. And for extra reliability, we added Azure Logic App to get notified through mail if the pipeline succeeds or fails. And then we also added another Azure service, which is Azure Monitor, to monitor the pipeline run. Now the data is in Azure Storage account. We will connect the Azure Storage account to Azure Databricks, do data cleaning there, and then finally move the clean data to Azure Storage account container named transform data, which we earlier created. And then after that, we will create Synapse Analytics and then find insights from the data using SQL. And then finally, we will connect Azure Storage account to Power BI to find insights from our data. Now let's create the Databricks. Now go to search and type here Databricks. Click on Databricks and click on create. Select the resource group. Now give the workspace name and it will be Azure UAE North and Databricks. Okay, and region will be UAE North. In the pricing tier, there are three options: standard, premium, or trial. And we will go with this standard. Next. Now in the networking category, when setting up Azure Databricks, one of the most important security settings is to deploy with secure cluster connectivity. This ensures your compute never touches the internet directly. Instead, traffic is relayed securely using Azure backbone networks. So we will select yes. Next option is deploy Azure Databricks Workspace in your own virtual network. What it means is, by default, Azure Databricks runs in a Microsoft managed VNet virtual network, but for enterprise projects, you can deploy the workspace inside your own virtual network. This is called VNet injection, and it gives you control over subnets, routing, network security groups, NSGs, and private connectivity. In simple terms, instead of Databricks living in Microsoft's network, it lives in your network, which is more secure and enterprise friendly. But for now, we will keep it no. Next. Now for the data encryption, Azure Databricks has two encryption layers, one for managed disks and another for managed services. By default, both are encrypted with Microsoft managed keys, but you can bring your own keys using Azure Key Vault. For managed services, this means your notebooks, job configurations, and metadata are protected with your own keys. And once enabled, it can't be disabled. Both of these options, once enabled, these cannot be disabled. But it gives you full control, key rotation, and compliance benefits. And since we have not selected the premium pricing tier, this is not available to us. Now the next option is double encryption for DBFS root. Enable infrastructure encryption. Now what it does is this applies a second layer of encryption so your data is encrypted twice, once with your key and once with Microsoft's key. This feature provides defense in depth and is especially valuable for industries that require maximum data protection like for the security and compliance. First option is enable compliance security profile. This option is basically for applying stricter compliance standards. Next option is enable enhanced security monitoring. And what it does is it continuously collects logs, detects suspicious activities, and helps with compliance reporting. And finally, enable automatic cluster update. Now the last option is enable automatic cluster update. Now, Databricks clusters run on Databricks runtime, which is updated regularly. If you enable this option, your clusters automatically get the latest patches and features. This keeps your environment secure, compliant, and up to date without manual effort. But since we have not opted for premium pricing tier, we cannot choose either of these options. Next, tags and skip tags, and next, click on create. It takes some time for Databricks to be deployed, so let's wait for it. So let's create this Azure Key Vault first. Open Azure in another tab. Now go to search and type here key and click on Key Vaults. Click on create. Select the resource group, and for the Key Vault name it will be Azure UAE North Key, and the region will be UAE North. Pricing tier will be standard, and days to retain deleted vaults will be 7. Minimum is 7 to 90. For example, if I say 6, then you can see it says the value must be between 7 and 90, so it will be 7. Disable purge protection, yes, it will be disable purge protection. Next. Now the permission models are role-based access control or vault access policy. Vault access policy is like giving keys to individual people one by one, while role-based access control RBAC is like giving people roles like manager or employee, and the role decides what they can do. Okay, so for now we will go with vault access policy. Now here you will select the user and what permissions you will give it. Okay, now you can see these are the permissions already given, and next, and you can save it from here. Okay, so next, and public access will be enabled and allow access from all networks. Private endpoint, we don't really need a private endpoint. Next, and click on create. Once the deployment is complete, click on go to resource. Now in here, you have to come under the objects secrets. Click on secrets and click on generate or import. Give the secret a name. I will give it secret KB. And for the secret value, now this value will be a access key from storage account. So let's go to the storage account and under the security plus networking, click on access keys. Now show this key and click on copy and paste it in here. Now all these things are optional, so it's up to you if you want to set activation date or expiration date, or if you want to add any tags to it. Otherwise it's good to go. Click on create. Now we have secret in place too. Now let's go back to the Azure Databricks and click on go to resource. Click on launch workspace. Now once Azure Databricks opens, the left menu is your control center. Workspace is where you store notebooks. Recents is what you accessed recently. Catalog is for governing data. It lets you organize data into catalogs, schemas, and tables. And you can see here is our meta store. Now for the other options, jobs and pipeline helps automate tasks. It will also include the job runs, and the final option compute is where clusters live. Here you create clusters and all your cluster related information is here. Now finally, job run contains information related to job runs, jobs and pipelines. It's very similar to jobs and pipelines too. And now for the rest of the features like playground, experiments, features, model, service, serving, these features are for machine learning. Now let's go back to the workspace and click on workspace, click on create and click on folder. Let's name it Azure Data Cleaning. And again click on create and here click on notebook. Now in order to securely connect Azure storage account to Databricks, we will need one more thing, and that is Databricks secret scope. So let's create it. Right click on this tab and duplicate it. Now what you are going to do is you're going to remove from editor till the question mark, okay, and after hash remove it, and here type secrets slash create scope. Once it opens, give the scope name. Let's give it a name as Databricks scope, and manage principal will be all workspace users. Now for the DNS name we need key vault, so go back to the key vault and under settings click on properties. Now this is the vault URI that you will copy. Copy it and then paste it in here, and resource ID, copy it and paste it in here. Now click on create. Okay, now copy this Databricks secret scope and okay. Now that the key vault and Databricks secret scope is created, we will connect Azure Storage account to Databricks and then do data cleaning there. Now mount storage account to Databricks. First, change the notebook name. That will be Azure or sales data cleaning. First, let's create the compute because it takes a lot of time for cluster to start. Let's rename it data cleaning, and policy will be unrestricted and Databricks runtime will be as it is. And make sure this option is enabled, photon acceleration. What it does is it accelerates your Apache Spark workloads, which reduces costs, and worker type will be as it is, and workers will be single because I am working alone, and terminate after 30 minutes of inactivity. The reason why I have entered 30 minutes is because what happens is sometimes we forget that the cluster is running and it costs money. All right, so that's it. Now click on create. Now until this cluster is running, let's write the code to mount Azure Storage account to Databricks. dbutils.fs.mount source equal to was :/ and here will be our container name @storage account name .blob .core .windows .net, and then here will be mount point equal to mount /mount/ container name. Okay, so what is our container name? For that purpose we have to go to the storage account, and there is a container, and this is our container name, raw data. So paste it in here, and for the storage account, what is our storage account name? This is our storage account name, and then paste it in here. All right, now extra configurations, it is equal to fs.azure.account.key.storage account name .blob .core .windows .net, and then there will be dbutils .secret .get and Databricks scope, and then key vault secret name. Okay, so what was our Databricks scope? It was Databricks scope, and key vault secret name is, there is a key vault and secrets. This is our secret name. Let's write it in here. All right, now cluster is running too, so let's connect our cluster and enter shift plus enter. Okay, now if I type here dbutils.fs.mount/raw data, Now you can see here is our files. Okay, so similarly we have to mount the other storage too. Okay, so for that purpose we have to copy this and paste it in here. Comment this out as this is already mounted, and for the raw data this will be transformed data and other things will be as it is. Run it again. Okay, it's saying true. True means it has run successfully. Now if I do dbutils dot fs dot ls slash mount slash mount slash transformed data, then it will say empty list because there is no data in here. Okay, so now let's load these files like accounts file, data dictionary, products, sales pipeline, sales teams into data frames. So accounts underscore df equal to spark dot read dot format, and it will be csv dot load dot option, and option will be header, and header will be true dot option infer schema true, schema will be automatically inferred dot load, and our we have to give our location here. Strings, and in between strings we have to give our location. Okay, now copy this and paste it 4 times. 3 4 5. For the accounts it will be data dictionary, data dictionary, and this will be products, this will be sales pipeline, this will be sales teams. Now if I say here accounts df dot show, let's show 2 rows. Okay, and now you can see here is our data. Now for the cleaning process, first let's see if our column names are as they appear. So for that we will have to print accounts df dot columns and print what is the next, data dictionary, dot columns, data dictionary df dot columns, and then products df dot columns, print date sales pipeline dot underscore df dot columns, and then print sales teams df dot columns. Now we can see columns are as they appear. Now we only need to fix these three column names because these are like first letter is capital, we need to small it. And for the subsidiary of, let's change it to parent company because it will look more good and more understandable too. So it will be accounts df equal to accounts df dot with column renamed, and it will be, what is the column name, subsidiary of, subsidiary of to parent company, to parent company. And similarly we need to change these things here. So data dictionary equal to data dictionary dot with column renamed, and table to table dot with column renamed, and here will be field will be renamed to field, and then dot with column renamed. Then again description will be changed to description. So now if I say accounts df dot show only one row, and you can see it is changed to parent company. And similarly if I say data dictionary dot show one, and you can see it's small characters now. Now what we will do is we will see if our table contains null values or not. So it will be null counts for accounts df equal to accounts df dot select sum when column for columns dot is null comma 1 dot otherwise 0 dot alias column for column in counts df dot columns. Yes, no, actually not right now. And let's do it for all the other columns too. 3 4 5. Okay, now let's change this to data dictionary, and this to products, and this accounts to sales underscore pipeline, and this accounts to sales teams. Now as you can see it's giving error, and when and column, basically we need to import these functions sum when column. So let's import it first from PySpark dot SQL dot functions import sum column when. Okay, all right, it should not give any error now. Very well, it's not giving any errors. Let's also display these null count table. Let's do it for all the tables. Now, as you can see, the account table does not contain any nulls except the parent company. It contains 70 nulls, and this is the data dictionary table, and this does not contain any nulls. And for the product table, there is no null, and for the sales pipeline, the account contains 1425 nulls, engage date contains nulls, close date contains null, and close value contain nulls too. And for the sales teams, this does not contain any nulls. So let's fix the nulls. So it's a very simple function, accounts df equal to accounts df dot fillna, and it will be parent company, parent company, and let's change it to independent. And what other table contains null? Sales pipeline. And then for the sales pipeline, equal to sales pipeline dot fillna, which of what is the table name, column name, account. And actually first we need to see what table actually contains. So it will be sales pipeline dot display. Okay, now as you can see, account is a string and it contains null. We can say here unknown. And for the engage date and close date, we cannot really do anything with it because these are dates and we cannot add any other artificial date. It will just mess up, or otherwise we can also not remove these nulls because these are a lot of rows. As you can see, 20, 89 and 500 rows. And for the close value, we can also not do anything in here, so we will have to leave it as it is because we cannot really do a mean or median or find or fill any other value here because it will just make the data less accurate. So we will leave other things as it is and we will change only account to unknown. Account colon unknown. So now if we again check the null values, let's copy this one and let's say null count dot display and you can see parent company does not contain any nulls. Now let's move this data to Azure Storage account container, transform data. So it will be accounts df dot write dot option and header will be true, and then there will be our CSV and here will be our location. And change the row to transform data, and similarly do it for all the other tables too. Oops. Let's do it for all the others. And this will be accounts TF, and it will be, and what is this table name? This is data dictionary. Data dictionary. And similarly, this is products. And this is sales pipeline. And this is sales teams. Sales teams. By the way, you can also change any name in here, okay? But I will just keep it as it is. But I will have to comment this out as this table was already moved accidentally. So let's shift plus enter. All right, now let's go back to the storage account, and in containers. Now you can see here is our data, like accounts, data dictionary, and products. Okay. All right, now the Databricks part is also completed. We will create a Synapse workspace and then find insights from the data using SQL. So let's create the SQL workspace. But first, you have to like terminate this cluster, otherwise it will keep costing you money. Okay, let's search here Synapse Analytics, and click on create. Select the resource group and the workspace name, and it will be Azure UA North Synapse, and region will be UA North. Data Lake Gen 2 from subscription, and account name we have to give the account name, and file system name will be transform data contributor. Make sure to do this. Assign myself the storage blob data contributor role on the data lake gen 2. Now in the security, for the authentication method, you can allow both local and Microsoft Entra ID authentication, which is flexible for legacy apps but less secure. Or for more security, you can enforce only Microsoft Entra ID authentication, which means all users and apps must sign in through Azure AD, Active Directory. So I will choose use only Microsoft Entra ID authentication, and next, and double encryption using a customer managed key. This basically means your data is protected twice, once with Microsoft's key and once with your key in Azure Key Vault. For example, if I enable it, then you will have to select the Key Vault and manage the identity. I will keep it disabled. When deploying Synapse Analytics, you can enable a managed virtual network. This means Azure automatically creates a private isolated network for your Synapse workspace. All your pipelines, SQL polls, and Spark jobs stay within Azure's private backbone. No public internet exposure by enabling this option. You can see create private managed endpoint to primary storage account, allow outbound data traffic only to approved targets, but we will keep it disabled. But remember, it is also the easiest way to boost security without managing complex networking yourself by enabling this managed virtual network. In Synapse, you will also see the option that says allow connections from all IP addresses. This basically means anyone on the internet can try to connect to your workspace. While it's convenient for testing or demos, it's not secure for production. In real world projects, you either restrict access to your own IP address or use a managed virtual network with private endpoints. This one here. But I will keep it enabled for now. And minimum TLS version, transport layer security version will be 1.2, and tags, skip, next. Now click on create. Wait for the Synapse Analytics to deploy. Once the deployment is complete, click on go to resource. Click on open Synapse Studio. Click here. This is the expand option. Now I will explain these quickly, and this is basically very similar to Data Factory. Azure Synapse Analytics has a very clean interface, and there are six main sections. And home is your quick start dashboard. It contains ingest, explore and analyze, visualize the documents and community here. Okay, and you can also create new SQL script, KQL script, notebook, data flow, Apache Spark, job definition, pipeline, import, etc. And data is where you browse and query your databases or files. Okay, and you can see in the link there is our data from Data Lake Storage Gen 2. It should be in transform data, and you can see this is the transform data, and this is the primary one which we set in during the setup of Synapse Analytics. Develop is where you write SQL scripts or Spark notebooks, and integrate is for building pipelines just like Data Factory. Like you can see here, pipeline, connection, data tool, browse, import. And monitor lets you check pipeline runs, Spark jobs and queries. And finally, manage is where you configure linked services, runtimes and security, very similar to the Data Factory one. Basically, you can do everything on Synapse too. Now you might have this question: if we can do everything on Synapse, then why would we use Data Factory? Well, Azure Data Factory and Synapse Analytics often get confused, but they serve different purposes. Data Factory is all about moving and orchestrating data pipelines, pulling data from multiple sources and landing it in a central store. Synapse, on the other hand, is about storing, querying, and analyzing data at scale. It's your data warehouse for BI and analytics. In real-world projects, they work together. Data Factory ingests and prepares the data, while Synapse makes it queryable and connects to Power BI for insights, which we have done so far. Alright, now go to data and click on plus, click on SQL databases and select SQL pool type, serverless or dedicated. We will do with serverless, and the database name will be sales. Now click on create. Now we have this database created. Now what we will do is we will create views so that we can access the data, access the data lake storage gen 2. So go to develop and click on SQL script. Now the database will be sales and connect to will be built in. To create a view, we have to write create view, and it will be dbo dot v accounts. This view is for accounts. Then there will be as select asterisk from open row set bulk. Now here will be our location. Now the location which will appear here is we have to go to the transform data. Now click on accounts, and this is our data. You can see it from here, view or edit. Okay, so copy this view properties and then copy this URL. All right, where is it? Okay, now write it in here, comma, and then format CSV, and then parser version equal to 2.0, and header equal to true. All right, now if I run it, oops, I did a mistake, and that is that I have to give the name as rows. Okay, now it's saying the query executed successfully. Now if I say like select asterisk from dbo dot v accounts, and let's say if I run it, then and this is our clean data, because you can see that this column which was initially subsidiary of this column name was subsidiary of, and we change it to parent company, so it means this is our transform data. All right, so similarly we have to create these views for other tab tables too. 3, 4, 5. All right, so let's go back to the data dictionary, and this properties URL, copy it and paste it in here, and change it to dbo.v. This is data dictionary. Okay, and similarly this one for the other tables, this is products. For products you can also copy URL from here, 3, this is it, paste it in here, and its name will be products, and similarly this name, its name will be sales pipeline, and its link is, copy URL, and finally for this one, this is sales teams, and for the sales teams, there it is, and copy URL. Alright, so let's run it one by one. First one is done, and for the next one, it says fail to establish connection to server. And why is that? Let's rerun it. Okay, it's saying unexpected token date at expecting tokens. Oh, uh, so we have to add some things here, and that will be we have to add field terminator and field quote. Okay, so it will be field terminator equal to comma and field quote equal to this. Okay, so now let's rerun it. Okay, it's a success now. Let's do this for all the other two. Successful, successful. Now let's run this table, this view finally. Alright, now all the views are created. Now if we go back and first refresh it, and then we can see here in the reviews, there is our views. dbo.v accounts, data dictionary, say products, sales pipeline, sales teams. Alright, so now we can query this data. Let's query the sales pipeline table. Select asterisk from sales pipeline from dbo.v sales pipeline. Okay, let's say we want sales agents for with close value greater than 2000. All right, select sales agent comma close value from dbo.v sales pipeline where close value is greater than 2000. Okay, now you can see there is our data. Now let's say order by close value and descending, and you can see that Rosalina Dieter has the highest close value of 30,288, then Markita Hansen, Elise Gluck, etc. Now similarly, let's find from dbo.v sales pipeline. Now similarly, let's find out which product has the highest close value. Okay, so it will be select product comma close value from DBO, where um, actually we don't need where, we need order by close value descending. Now we can see GTK 500 has the highest close value, and which is 30,288. And then comes the GTX Plus Pro, and then GTX Pro. Now for the final part, we will send transform data to Power BI and visualize our data there. So now let's search here Power BI, Power BI desktop. Once the Power BI opens, click on blank report. Now we have to get the data. So click here get data, more, and you can see here is our formats, and click on Azure, and here Data Lake Storage Gen 2. And here we have to give the link for our container. So click on here three dots and container properties and copy this path. Now go back and paste this URL. One thing you have to take care, and that is that instead of blob, write DFS here. Now there are three ways to connect storage account to Power BI. First is organizational account, second is account key, third is shared access signature. We will do the account key. So go to security plus networking and access keys and click on show and copy this key and paste it in here. And you can see here is our data. Click on transform data, and from here these .csv files are actually our files. So let's click on this first CSV file. Click on binary, change the name to accounts, and then close and apply. Similarly, we get data for the other tables. Data like Gen 2 and the URL, which is transform data, this container properties URL, copy the URL and paste it in here. This is DFS. Again transform data. Now click on the second CSV file. Change the name to data dictionary and close and apply. Now repeat this process. Azure Data Lake Gen 2 and the URL, change the blob to DFS and transform data. Now the third CSV file, change it to products, change the name to products and close and apply. Now again get data, Azure, from these Azure Data Lake Gen 2, URL, blob will be changed into DFS, and then OK, and then transform data and select the fourth or second last CSV, which is this. And now change the name to sales pipeline, close and apply. Alright, let's do it for the last table, which is Azure Teams. Sorry, which is sales teams. Blob dot blob, instead of blob there will be DFS and OK, and transform data, and the last CSV file, change the name to sales teams and close and apply. Alright, we won't really need the data dictionary because it's just the explanation of the columns, so we won't be needing it. But for the sales teams, why is it column 1 2 3? I think we did a mistake there. We will have to get data again for this table, so let's delete from model, yes, and then get data, Azure Data Lake Gen 2, DFS, transform data, and go to the last one. Alright, so we have to do here, use first row as table, as headers, and let's give it a name as sales underscore teams and close and apply. Okay, now its name is clear. Let's find which agent did the most sales. So for that, let's go with stack bar chart. So there will be sales agent will go on x-axis and on y-axis, and on x-axis should be close value. Let's say, let's set it to count. No, actually let's set it to sum. And also let's add if the deal was positive, if the deal was won or not. Let's add the filtering to top and this will be top 5. And what will be here? By close value, by close value. I think the reason it's not showing lost and it's showing 1 is because it's set to sum. Let's set it to count, and there it is. There is a lost and 1 values. All right. Now let's do now now let's add a line chart. Now what should we add in line chart? Let's say total sales. Let's say total sales by month. Okay. So for the total sales, we will take close value, and we will add it to y-axis, and for the x-axis we will add close date, and let's remove the year, quarter and month too. Okay, so this is the sum of close value by month. And what will be the next chart? Let's create a map. What can we add in map? Map should be office location. Office location can be added in map, and we can say uh, which office has the highest revenue. Yes, we can say that. So office location will go to location, and revenue will go to legend. Legend, or let's put it to bubble size. It will increase the bubble size, and you can see here. You can see in United States count. Why is it count? Oh, sum of revenue. Okay, so United States has the highest revenue in selling their product. All right. So the next thing we will add is uh, we will say which company has the highest revenue. Okay. So let's make a funnel chart, and account will go to category, and revenue will go to values. sum of revenue, and we will have to make it top 5, and it will be set to by revenue count, not sum of revenue. Okay, so these companies has the highest revenue. Now let's say which product won the most deals. Okay, deal stage and product we will need. So its chart will be, we have not added a column chart, right? So let's add a column chart, and it will be product will go to x-axis, and ID will go to the y-axis, and for the product, and let's add a deal stage here for 1, the deals which were 1. Yes, so which product won the most deals, and that is GTX basic, 915 deals. Now let's add another chart, and this time it will be, let's add a revenue by office, revenue by sector. Yes, let's do this, revenue by sector, and let's add a donut chart, revenue by sector. Now sector will be top 5 by revenue. So these are the top 5. So let's rearrange it, and this will go in here, this will go in here. Okay, and let's add it in here, and this should be here. Okay, all right, now let's add some KPIs. So now the first KPI will be a card. let's say total deals. We will need here close value count. So close values are 6711. Okay, similarly we will make another card, and this time it will be for the deals which were won. Close value and count and deal stage is 1. So here goes the second one, and for the third one we will add the deals which were lost. So close value count deal stage and lost. Let's add another card, but this time it will be for the win percentage. So let's go here and click on new measure, and the measure will be win rate win rate percent percentage. So it will be divide, we will divide calculate count of rows and sales pipeline. Sales pipeline, this time it will be deal stage. Deal stage equal to 1. Equal to 1. And then calculate count rows sales pipeline comma sales pipeline for deal stage in one comma lost. Comma 0. So where is it? Sales win rate will go to fields, and here is our win percentage. Now let's add a title, and this will be Azure Project Report, and let's make it 20 and highlighted. Center and make it 32. What happened? Okay, so now let's do. So now let's remove these lines and center the titles. So let's data labels will be on. Okay, colors are okay. Title will be total sales, sum of so the title is okay, but we will center align it, and it's okay. And for this, first of all, center align it, and let's rename it to total sales by month. And let's remove no, not the date, not the values, but grid lines. Yes, remove the grid lines. Title remove, y-axis title should also be removed, and then for this, let's make it middle, and otherwise it's okay. And let's do, let's change its title, it's too big. Let's change it to total sales 1, total sales by agents. Okay, it's all right. And for the title should be removed, and x-axis title should also be removed, and grid lines will be removed, and then title will be in the middle. Okay, and its title should also be in the middle, and its title will be renamed. And let's change it to number of won deals for each product. All right, and its grid lines will be removed, y-axis title will be removed, x-axis title will be removed, and okay. All right, and for the donut chart, let's change its name to revenue by sector. Revenue by sector. Now let's delete the resources, and it is actually very important that you delete these resources, otherwise it will keep costing you money. So how to delete it? And to go to resource group, click on the resource group. By the way, you can see all the other resource groups except this network watcher RG, and these resource groups will automatically deleted once you delete this resource group. You can also go to each of these services and then delete it individually by, for example, delete this from here, or you can also delete all these services by clicking the resource group. By clicking here, click on delete resource group, copy this name and paste it in here. Now you can see all these services will also be deleted. Databricks, Data Factory, Keyword, Logic App, Storage Account, Synapse Workspace, Connection, which we created in this project. These will automatically be deleted. Okay, so click on delete and delete.